All right, guys, good morning. Welcome back. I will not be here today, obviously. You're going to be watching this recording and taking notes and submitting the notes as your daily assignment. This is how I will take attendance. If you do not turn it in, you will not be counted present for the day. Okay? So we are on 2.7, or in our curriculum, it is 3.5. This is after that word problem strategy guide problem we did together. It was just a proof. We're going to prove angled pair relationships. Angled pairs. Pairs mean two. Okay, so we're going to be looking at pairs of angles and their relationships, and we're going to prove them, basically to create shortcuts for us for other proofs. Now, we are in proofs now. We are, we haven't begun them. We are in them now. So you need to do the following, okay? You need to create a vocab list of reasons. Think of this as like a cheat sheet. Okay? So I want you to get a piece of paper or a PDF or like Word document or something. Probably a piece of paper would be better because we can include drawings and things like that. And keep it aside from your notes, but with your notes. Okay? And every time you see a new reason, every time that we use a new reason on the right-hand side, include it. Add it. Give an example as to when it would be used. Maybe put it in your own words. This is when I would use this. And this way, when you're going through proofs, you have something to look at and to refer to. Guys, these proofs are just like you start at some place, okay? And then you have to hop and skip over these rocks, right, to get to the finish line, right? Okay, so that's kind of like what we're doing here. You have to keep that in mind. It kind of helps. All right, let's go ahead and just go through them. We did this one in class already. We did this as for due now a couple days ago, so you should already have that in your notes. We're going to continue with the first theorem, which is the right angles congruence theorem. Let's read through this together. Sometimes a new theorem describes a relationship that is useful in writing proofs. For example, using the right angles congruence theorem will reduce the number of steps you need to include in a proof involving right angles. Okay, think of it as a shortcut. All right. So the right angles congruence theorem is very straightforward. It simply says all right angles are congruent. Okay, an example. When you would be able to use this, we'll use it after we prove it, but just to give you an example, we would say that angle 1 and angle 2 are right. You'd be able to identify that by a marker in the diagram or being told some other information. Maybe that was given to you, okay? And then you'd be able to say, okay, angle 1 is congruent to angle 2. I already know that because of the right angles congruence theorem. Okay, so this allows us to go right from being told that they're right angles right to being told that they're congruent. And if they're congruent, of course, they're equal, and that'd be the next line. So let's go ahead and prove the right angles congruence theorem. Before we use something, we should prove it. If you need to, I'd recommend you pause this and think about things. All right, identify those steps that we're stepping on to get across to the finish line. All right, think of it like crossing a river. All right, but you need to be aware of the rocks you're standing on. Okay, otherwise you're not going to be able to do this path on your own. Okay, so we are starting here, right, and we want to end with them being congruent. We can't use the right angles congruence theorem when we prove it. Okay, so we have to use other stuff. All right, so think about, where does being right lead you? What does it mean to be a right angle? If you know what right angle means, you can relate this to something else. Remember, if we can get into equation world, like algebra land, then we can use all the properties of algebra. And those are, there's a lot of them, so it's useful. Okay, so is there any way I can turn this into an equation or an equality? Yeah. What does it mean to be right? It means to be equal to 90 degrees. So we could write the measure of angle 1 is equal to 90 degrees. And I can see that the measure of angle 2 is equal to 90 degrees, right? How did I know that? Well, I know what the word right means, and hopefully you do too. I know what the word means. That's called a definition. So whenever you're using your knowledge of what a word means, it's called a definition. In this case, it's a definition of right angles. Okay? All right, now what can we do with this line? 1 is equal to 90 and 2 is equal to 90. Two things equal the same thing. What do you think I could do as I stroke my beard here? Maybe some of you are seeing it, right? If I'm as tall as my dad and my brother is as tall as my dad, well, then I'm as tall as my brother, right? Remember that? Okay? So if these two things are equal to the same thing, well, then they're equal to each other, right? The measure of angle 1 must then therefore be equal to the measure of angle 2. This leads me here. What property did I use to get there? Pause and try and answer for yourself. Okay, if you don't know, put this in your vocabulary list of proofs, proof reasons, okay? It's the transitive property. You may also want to think of this as perhaps substitution. That would be acceptable because all I'm doing here is replacing 90 with what 90 is equal to, which is 2. Okay. Last line, well, I shouldn't have told you that last line, but think about this. What's the natural consequence of being equal? Remember where we're trying to go. We're trying to show that they're congruent. Well, if two angles are equal, then two angles are congruent, right? Angle 1 is congruent to angle 2. And how do I know that if things are equal, that they're congruent? Well, I know what the word congruence means, all right? So line 4 would be another definition. In this case, definition of congruence. I want to put in parentheses here, there is never a definition of equality. We never use definition of equality for whatever reason, we just don't do it. Okay? I would write that down and I'd read through it again just so you get the feel for what's going on. Alright. Alright, now we are not going to use the right angles congruence theorem. We're going to use right angles congruence theorem in this proof. It's just notice the exact same thing. So here we're going to not use right angle congruence theorem. Okay. Next one we will. Just to show you that it is a shortcut and it does help us. Alrighty, so what is a consequence? Before we even begin, really, we should take inventory. Like, look at the diagram, realize we have these markings. Okay, they should tell you a little something. Realize that they give us this information, right? This is where we start, right? That's the given information, and we're trying to get here, them being congruent. All right, so what is a natural consequence of AB being perpendicular to BC, right? As indicated by these congruency markers here. Come on. What, I can't switch anymore? All right. What does this marking mean to you? It means perpendicular. What does it mean to be perpendicular? What can you tell me about angle B? Angle B. Oh, and what other angle? This angle. What is this angle? What can you tell me about angle C? And angle C are what? They're right. Okay. How did I know that they were right? Because I was told that they're perpendicular. And I'm a good geometry student, so I know what the word perpendicular means, right? If you're using your understanding of a word or a concept, what is it? It's a definition. perpendicular. Perpendicular, of course, means to meet at right angles, intersect at right angles. Okay? We've been here before. What is a natural consequence of B and C being right? What else can I say? Can I get into algebra land, right? Can I get into equation world? Yeah. If B and C are right, what do they equal? They equal 90 degrees. So the measure of angle B is equal to 90, and the measure of angle C is equal to 90 degrees, right? How did we know that? Well, I know what the word right means. Right means to be 90 degrees. So the definition of right. Okay, we've been here just recently. If these things are both equal to 90, these two distinct things, what can I say about these two things, right? If this is equal to 90 and that's equal to 90, what can I say about these two things? They must be equal to each other. Okay? I know I'm kind of rushing through this, but I want you to pause if you can. When I ask you questions, pause and try to answer them yourself. Right? You're not going to get better at this if you don't take the steps. I can't think for you, but I can shine the light down the path, right? You can follow me down the path, but I want you to take the steps. All right, so how did they say these are equal, right? If I'm as tall as my dad and my brother's as tall as my dad, then I'm as tall as my brother, right? Transitive property. You could also make an argument for substitution. All right. If two angles are equal, then what else could I say about those two angles? Remember where I'm trying to go. Oh, they're congruent. Right? How did I know that they were congruent if they were equal? I know what the word congruence means. Definition of congruence. All right? Now, we didn't use right angles congruence theorem there, and it took us 5 steps. Now we're going to do the same proof, but utilizing the right angles congruence theorem. Okay? So you tell me. Here, this time we're going to use the right angles congruence theorem. What does it mean to be perpendicular? It means to intersect at right angles, right? So what angles are right here? Angle B and angle C are right. How did I know that they were right angles? I was told they're perpendicular, right? Definition of right angles. Now, what's right angles congruence theorem say? It says that all right angles are congruent. Okay, what do I have here? I have 2 right angles. Therefore, what are they? They are, they are congruent, right? Angle B is congruent to angle C. And how do I know that? Because of the right angles congruence theorem. Okay, so this is the first time we've used it in a proof. It's a nice shortcut. Notice how we went from 5 steps to 3 steps, or 3 steps. Cool? All right, here's 2 new theorems. I want you to copy them down into your notebook. Okay, pause the video, write it down, read the words. If 2 angles are supplementary to the same angle, okay, 2 angles are supplementary to the same angle, what's it mean to be supplementary again? Remember that definition? Supplementary means to some to 180 degrees, okay, then they are congruent. Let me lock this up. So they say angle 1 and angle 2 are supplementary. Okay, that's a pair. Then they say that 3 and 2 are also supplementary. So think about this. If 1 plus 2 equals 180 and 2 plus 3 equals 180, well then, and 2 is the same in both cases, then this has to be the same, right? Let's give you a quick concrete example, right? Let's say that this was 150. Angle 2 is 150 degrees. 1 and 2 are supplementary. So what does 1 have to be? 180 minus 150, 30 degrees. Okay? 2 and 3 are also supplementary. Can 3 be something different? No. 3 has to be 30 degrees as well, right? And so it's clear to see that 1 and 3 must be equal. They must be congruent. We have an analog with complementary. So the same thing, the same kind of line of thinking applies here. If two angles are complementary to the same angle, then they are congruent. This also is true with congruent angles, but we'll get there. So 4 and 5 are complementary, and 6 and 5 are complementary. Same idea here, right? We'll do a concrete example. Maybe 5 is, by the way, what's it mean to be complementary? What does that mean? It means to sum to 90 degrees, right? You can think of it as, complement always makes everything right. Get it? Okay. So if this was, let's say, 50 degrees, what must 4 be if 4 and 5 are complementary? 90 minus 50 must be 40, right? If 5 and 6 are also complementary, what must 6 be? Oh, it must be 40. What do you notice? These are the same angle, okay? So these are just another way of showing two angles are congruent, all right? Here we're going to prove a case of the congruent supplements theorem. And once we've proved it, we can use it, which means we have another shortcut. Okay, so we're told that 1 and 2 are supplements, and 3 and 2 are supplements. We can't use the theorem when we're trying to prove the theorem. All right, we want to show that 1 is congruent to 3. All right, so here we have a whole lot more written, but we're just going to fill in the blanks. Maybe you can do this on your own. All right, we're told this, we're given that. Then they cite the definition of supplementary angles. So what does it mean to be supplementary? It means to sum to 180 degrees. So we should show that if that's what we're citing. If 1 and 2 are supplementary, then the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. If 3 and 2 are supplementary, well then what's that mean? The measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. Okay? Then all of a sudden they set 1 plus 2 equal to 3 plus 2. How could they have done that? Let's look. They both equal the same thing. So we've seen the situation just a little bit above here, right? Two things are equal to the same thing. What are they? They're equal to each other. What could you cite for a reason? You could cite the transitive property, or you could also make an argument for substitution. Okay? Hold on a second, my daughter's upstairs screaming for help. Okay, sorry. Where were we? Okay, so If two things are ever equal to the same thing, of course we can set them equal to each other via transitive property or substitution. Next thing they say is that we cite the subtraction property. Well, we use the subtraction property when we subtract something from both sides of the equation. What can we subtract from both sides of the equation here? We can only subtract something if they're the same thing. What do you have on both sides of the equation, which is the same thing? 2. So what will I write? Measure of angle 1 is equal to the measure of angle 2. Okay? Oh, I'm sorry. Oopsies. I should have said 3, right? We crossed out the 2. All right, so if two things are equal, then they're congruent? Well, yeah, right? How is that? The definition of, not equality, congruence. By the way, guys, this came up a couple times yesterday. It is a trick question. If you ever see proven as the last reason, it's never that. Okay, they're trying to trick you. Okay, that's proven is not a reason. It's a way to get people who don't know what they're talking about or not paying attention to select the wrong answer. So you don't want to be that guy or gal. All right, so we just proved the congruent supplements theorem. All right, we have a couple more here. This is the linear pair postulate, sometimes endearingly referred to as LPP. Okay, if two angles form a linear pair, then they are supplementary. So this is not the definition of a linear pair. Okay, this is the linear pair postulate. The definition of a linear pair is two angles which share a common side and whose non-common sides form opposite rays. Okay, that's the definition. We're using the linear pair postulate, which says that, hey, if two angles are a linear pair, then they are supplementary. Notice how this is inside conditional statement form with the if and the then. Okay, so keep that in mind. So here's just a line of reasoning here. If angle 1 and angle 2 form a linear pair, which you can identify by the definition, like if this was laying in a diagram, I could say, okay, angle 1 and angle 2 are a linear pair by definition. Then I could say, so angle 1 and 2 are supplementary, right? This is the LPP, the linear pair postulate. And then we can say that they sum to 180, right? And that's the definition of a linear pair. I'm sorry. That's the definition of supplementary. Okay, so see how one thing leads to another, right? Like the first thing we said was they were a linear pair. That would be by definition of a linear pair. We can look at it and identify it. Like I could look at a gazelle and be like, that's a gazelle. I know what a gazelle looks like. I know what a linear pair looks like. So it's a definition. All right, then we have the vertical angles congruence theorem. By the way, we're going to be using these two a lot. So a lot more than the other one, the congruent supplements theorem. These two get used over and over and over again, used and abused, okay? The vertical angles congruence theorem says vertical angles are congruent. All right, what are vertical angles? We've drilled this before, but vertical angles would be like 1 and 3, or like 2 and 4. Okay, so vertical angles share a vertex and their sides form opposite ray pairs, right? Like if you look at the sides of 2, those are the sides of 2, they form opposite ray pairs with the sides of 4, so they're vertical angles. So that's straightforward. Identify vertical angles, then vertical angles are congruent. If they're congruent, they're equal, then we can substitute them for one another, so on and so forth. All right, we're going to prove the vertical angles congruence theorem. Once we prove it, we can use it. So angle 5 and angle 7 are vertical. Okay, that was given. We want to prove that 5 is congruent to 7. Remember, we can't use it when we're trying to prove it. 5 and 7 are vertical, it's given. Then they say a definition of a linear pair. Okay, do you see any linear pairs here? I see some linear pairs. Can you name some linear pairs? two angles that share a common side and whose non-common sides form opposite rays? Yes, I see a couple pairs. I could say that angle 5 and angle 6 are a linear pair. By the way, the word line is in the word linear, so you can remember that they form a line together, right, when you add them up. And looks like angle 6 and angle 7 are a linear pair. Okay? And that's by definition a linear pair. If you're identifying something, it's a definition. If you're identifying something, it's a definition. Okay, so now we've said that 5 and 6 are supplementary. How do I go from a linear pair to saying that they're supplementary? It's not by definition of linear pair. Remember, that would be the linear pair postulate. If I go from linear pair to supplementary, it's the linear pair postulate. So this would be the linear pair postulate. Remember that it's a postulate because it's so obvious it doesn't need to be proven. Or referred to as LPP for short if you're trying to use shorthand. All right, so now we're going to use the congruent supplements theorem. Remember what the congruent supplements theorem said. It said that if two angles are supplementary to the same angle, then those two angles are congruent, right? What two angles are supplementary to the same angle? 5 is supplementary to 6, and 7 is supplementary to 6. So remember, all the way back up here, right? It would be said that if two angles were supplementary to the same angle, they must be the same. And we did a little concrete example of that with numbers. So what two angles are the same here? Looks like angle 5 must be congruent to angle 7 because they're supplementary to the same angle, which is 6. That's the congruent supplements theorem. Okay, so we threw a lot at you this section, and if your head's spinning a little bit, that's okay. We will have practice with it, but I want you to start creating that one page of all those reasons on the right-hand side. We're getting a lot of them, so you need to keep them straight in your head. What did we learn in this section? We learned a lot. The right angles congruence theorem. Okay, it's a nice shortcut. Actually, all of these are. We learned the congruent supplements theorem. If two angles are supplementary to the same angle, then they are congruent. That has the same thing for complementary. We learned the linear pair postulate. We're going to use the linear pair postulate a lot. All right, if two angles are supplementary, if two angles are a linear pair, then they're supplementary. All right, and the vertical angles congruence theorem, probably the most used, other than transitive, okay? If you see a pair of vertical angles, they must be congruent. All right, that's the section. Turn in these notes, and that'll be that. All right, please make sure you're starting to keep that list of reasons. At one point, I will want to see it, and it will help you, I promise. All right, guys, you have a great day. Oh. If I can ever turn this thing off. It's just thinking.